Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Continuous delivery lets you get new features in front of your users as fast as possible without introducing bugs or breaking production, and GoCD is the open source platform made by the people at ThoughtWorks who wrote the book about it. Go to dataengineeringpodcast.com/GoCD to download and launch it today. Enterprise add-ons and professional support are available for added peace of mind. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. I've got a couple of announcements before we start the show. There's still time to register for the O'Reilly Strata Conference in San Jose, California, happening from March 5th to the 8th. Use the link dataengineeringpodcast.com/strata-san-jose to register and save 20% off your tickets. The O'Reilly AI Conference is also coming up, happening April 29th to the 30th in New York. It will give you a solid understanding of the latest breakthroughs and best practices in AI for business. Go to dataengineeringpodcast.com/AICon-new-york to register and save 20% off the tickets. Also, if you work with data or want to learn more about how the projects you have heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to dataengineeringpodcast.com/ODSC-East-2018 and register. Your host is Tobias Macey, and today I'm interviewing Rajan Dhabalia and Matteo Merli about Pulsar, a distributed open-source pub/sub messaging system. So, Matteo, could you start by introducing yourself?
Sure. Hi, Tobias. So my name is Matteo Merli. I work on Pulsar, and I used to work at Yahoo for several years on pub/sub messaging, distributed database replication, and various infrastructure tasks. And I continue to work on the project and trying to bring it forward with new features and new bugs.
And Rajan, how about yourself?
Yeah, sure. So my name is Rajan Dhabalia, and I'm working on Apache Pulsar project in Yahoo. And before joining Yahoo, I've been working with different teams related to platform and infrastructure and building various distributed systems. And a few years back, I have joined Yahoo, and since then, I'm working on Apache Pulsar, and I'm also working here on distributed storage system, which is nothing but storing the distributed key value pairs. Yeah, so that's it.
And going back to you again, Matteo, do you remember how you first got involved in the area of data management?
When I started working at Yahoo, I started working on database replication. So Yahoo has a massive database that is originated from the old Peanuts paper, and one of the critical part of that system is the moving data basically from different regions. So you have a database in which updates is an eventually consistent database, so events can come from different regions and has to be reconciliated, but data has to be moved across different data centers at a massive scale. So that's what the first project that I started working on, and that's where I started seeing copious amount of data and moving this data around.
And Rajan, how about yourself? Do you remember how you first got involved in the area of data management?
Yeah, so before joining Yahoo, I have been working on various distributed systems where it basically strongly requires various messaging in the database system. And regarding messaging, we have been working on different messaging system with a very large scale of data. And regarding the database, we also had a huge requirement of building a system which basically requires the replication of the data between different clusters. And then I joined Yahoo, where it caught my eye, where Yahoo was building a distributed messaging system, which is right now known as a Pulsar. And then I joined Yahoo, and that's where I started working on Pulsar, where at that time it was basically started developing, and then it's getting matured with the time, and many different teams have basically started onboarding on Pulsar to basically satisfy their asynchronous behavior and PubSub requirement. And now large portion of the Yahoo they have started using the Apache Pulsar on a very heavy and heavy basis. Yeah.
So, can you explain what the Pulsar project is and what the original inspiration for the project was, particularly given the fact that there were existing publish-subscribe systems?
The main reason was that at Yahoo we realized, so the reason for PubSub is that that many groups were using that on their own. There was no central system at Yahoo for messaging. So basically, every team was on its own, and every team would choose a different solution. Either could be ActiveMQ, could be Kafka, could be many different ways. But the problem there was that each team didn't have the necessary the operational expertise to operate the system for critical projects, and also there was like a lot of duplicated effort in around monitoring, around how do we operate it, what do we do when these things fail, and so on. So there was a push to have a single service for the whole company. And when we started that, we basically evolved these from other proprietary Yahoo systems, and trying to figure out if we could leverage anything that was out there in the open source, and what was the best solution and the best approach for the task. And so immediately we tested out all these available solutions, but we couldn't find anything that was able to scale to the point that we could support the internal use cases, all in a single cluster, or even some of the most demanding use cases, especially with requirements in terms of durability, in terms of what's the kind of latency that we can offer, some kind of SLA, and in terms of operating a very large cluster. So that's when we sat down and started designing from the ground up. So we took a Bookkeeper, which was another Yahoo project, and that was for a storage part, and eventually we evolved in a way that we built our own broker on top of it to have a very lightweight broker component that could leverage the horizontally scalable storage for Bookkeeper.
Actually, yeah, I would like to also add a few more things why we have seen that Pulsar could be the right use case, right system to basically bring in the Yahoo. So in Yahoo, we have most of the teams basically, after learning most of the team's requirement, we have realized that we have three fundamental requirements which we exactly need in Yahoo, which was not basically available into other PubSub messaging framework in the market. The first one was the throughput and the performance. So in Yahoo, we have many applications which requires strict SLA in terms of the publishing the message. We have one of the biggest system, Sherpa, which basically requires 5 milliseconds of publish latency. So as Matteo mentioned, Pulsar has two major components. One is the broker, and second is Apache Bookkeeper. So Bookkeeper is basically a persistent storage system where Pulsar basically persists all the published messages. So this Apache Bookkeeper basically architecture basically fulfills this requirement regarding the throughput, because the Apache Bookkeeper, so each individual node basically known as a bookie, and Bookie's architecture basically helps us to isolate the IO operation for the read and write, because in Apache Bookie, the read and write basically happens into different execution path, where whenever any message will be published, or if you want to persist any particular message into Bookie, Bookie has its own journal. So if for one individual Bookie node, it basically has its one single journal where it basically appends the message, which is basically write ahead log, and it basically appends every write, and it basically does those write basically periodically flushed into the dedicated separate storage device in the background. So whenever any reads would happen, that would basically happens from that separate storage device. So if any consumer tries to read as far as possible, it can basically saturate the IO, but then it basically impact the storage device. It won't basically impact the actual journal device where we are writing. So if we have consumers where basically they are reading as fast as possible, even if the IO will be saturated, it won't impact the published latency. So the published throughput was the main use case. The second was the scalability. So right now in Yahoo, for one of the cluster, we are having more than 1 million topics. So yeah, Pulsar is basically serving more than 1 million topics in one of our cluster. And that scalability basically can be achieved in Pulsar because if we consider another PubSub framework, which is, let's say, Kafka. So in Kafka, every consumer basically can read from one partition. So basically, creation of the number of partition is basically consumer bound. Now, so now within Kafka, if let's say if we have a topic and if we are basically having dedicated file or directory for every topic, then all the IOs can be scattered in various different directories, and then basically scatter the IOs. So it basically direct impacts the IO read operation, because it has to basically flush the page cache and periodically. In Pulsar, we are using the Apache Bookkeeper, where it basically aggregates multiple topics messages into one large log file. So it basically prevents that IO scattering, and then it gives the more scalability in terms of the IO throughput as well. And the third main use case was the geo replication, where in Yahoo, for most of the application, we need to replicate the message from cluster A to, there are multiple different regions are available where we have to basically replicate the messages. So in Pulsar Broker itself basically takes care of the replication of the from one geo cluster to the another different geolocation. So in that way, it won't require any user intervene, or it won't require any user attention while replicating the message, because Pulsar Broker server side will be basically taken care. So these are the three main fundamental use case, which were like a strong requirement we had in Yahoo, and that motivated us to build Pulsar.
And there are a few questions that I have coming out of that. One of them is for the georeplication. You mentioned that the Pulsar layer is what's responsible for handling the distribution of the messages to those distributed clusters. So I'm curious if it's essentially just replaying the message as a publish event to the other clusters. And it seems that way the underlying bookkeeper layer doesn't have to have any understanding of the separate clusters as far as distributing the data in that manner. Is that accurate?
That is correct. So actually, the main kind of replication is async replication. So this is being handled broker to broker. As Rajan was mentioning, that's a very core feature of the system. So it's not some tool that you have to run. Is a property that you configure, that I say, I want my topic to be replicated in region B, A, B, and C, and the system will take care of it. The other kind of replication, the sync replication, you can still do in that by placing storage nodes in different clusters and using Rocker policy to make the data being present in both clusters. And that would be a sync replication, and it's actually a single logical cluster with data scattered across multiple regions. So that's more like of a deployment configuration choice.
And then on the persistence side, is it tunable as far as the level of consistency that's required for a write to be acknowledged, where you submit the publish event to Pulsar and then it requires some number of nodes to acknowledge the write before it will return back to the person doing the publish that it was successful?
Yes, that is correct. So in Bookkeeper there are different tunables that you can configure, but so it's the replication model for Bookkeeper is very different from what it is for Kafka, and it has several advantages with Bookkeeper and Pulsar. So as we say that we have two different layers. One is the broker, one is the storage, and that gives you a complete decoupling from where the data has to be stored and where the data is being served. And that is much more flexible. Yes, you can configure a multiple the level of replication that you want, and you can also configure different ways how to distribute the data across different storage nodes. So, for example, you can say that I want 2 copies, or I want 3 guaranteed copies, but I want to write 1 more copy and wait for 3x or 2x, for example. So you can trade more writes for lower latency. And that's something that it can help a lot in reducing the latency, because it can prune out the slowest node.
It also basically, we can also tune the replication factor per tenant level as well. So in Pulsar, every tenant basically can have their group of topics, which we call as a namespace. And that replication factor can be tunable per namespace level. So it basically, we can basically tune at tenant level as well. So it can be basically configurable as per the tenant requirement.
And do you provide a sort of general purpose set of defaults for when you install the clusters, so that you don't have to worry about working with all those different parameters when you first start working with the software? Because sort of the general issue of usability versus configurability is a spectrum of, if you have too many knobs to tune, then you're not quite sure which ones to tune, and you can actually make things worse than they started off. So
yes, so the default is to have 2 copies of the data, and so write to storage nodes and wait for 2 acknowledgements. So that gives you the 2 copies variability, and that's the default. And of course, it's tunable, so you can change the default for the whole cluster, or you can change the setting for a particular group of topics.
And what have been some of the most challenging aspects of building the Pulsar project, as well as promoting it outside of Yahoo and gaining interest in the project itself?
Yeah, these are very, very different challenges. So for building the system, I would say that the main challenges were basically on the scalability part. So how to design a system that has to be able to scale in very different angles, in throughput on a single topic, in number of topics, and adding new nodes, and also the operations part are very critical. Once you reach a certain scale of operations, that all the tools and the reliability of these tools and these operation needs to be very, very, very solid. And also how does it track the system when you put any kind of different workloads in the same cluster, how to make sure that a tenant doesn't affect the workload for other tenants. I don't know if Rajan has other things that...
Yeah, I think we covered everything. So I think the catching the more attention from the outside of Yahoo or to large community, I think the project has to have solid infrastructure in terms of building a system more reliable, and then providing the monitoring APIs, and also providing some easier way to deploy the service, which is Apache Pulsar service, into various cloud providers. So I think Apache Pulsar as a community has many different contributors have contributed a lot in terms of making Pulsar more reliable, and providing different solutions where people can easily come and then they can deploy in various different cloud providers like AWS, Google Cloud, and they can basically start with Pulsar very quickly. So it basically gives a very fair idea to user that how quick it would be to deploy, and then once they start using it, the throughput and the scalability which Pulsar provides, I think then they will basically start realizing the main idea behind using Pulsar as a PubSub messaging framework with the use cases. So I think there are a lot of things have been done, and we have been trying we are putting our consistent efforts to taking it more further and forward.
Yes, on the adoption part, I was just add that. So one of the main challenges there is that, so this is a critical part of infrastructure. So it's not some project that anyone can take easily on. So there's a lot of work to convince people that this is a valuable alternative to other established projects, and that is worth giving a try, because we believe that many of the operations, many of the scalability issues are not an issues with Pulsar, and there are several advantages.
And how much has the overall system design and architecture evolved over the course of the project's lifetime? And are there any decisions that were made early on that have proven to be problematic for being able to grow and evolve the project as new use cases or requirements are introduced?
I don't recall any like big obstacle. So I think that the architecture is very solid in the sense that, so the main idea with Pulsar is that you have a pub/sub layer that is based upon a distributed log, and that's a very flexible architecture, and that basically it lets us support very different use cases. For example, like with Pulsar, you can have different types of consumers. So you can consume data either in order, like you do in Kafka. Basically, you have a topic, you have partitions. You can have a consumer per partition that consume all the data in order, but you can also use the more traditional queue approach, in which you have a single shared queue, in which you have multiple consumers that are all taking items out of the same queue. And can support this because we have this distributed log underneath, and then we have this serving layer, which is the broker on top of it. So that has not changed since the inception. We've been just adding a few more features here and there. We've been adding more components, but not really any dramatic changes from the beginning.
And for somebody who wants to start using Pulsar in their own environment, what are some of the infrastructure and network requirements that they should be considering, and what's involved in deploying those various components?
There is no like special requirements. The minimal requirements are very usual. Like I would say that at least 3 nodes if you want to have the data replicated. In terms of deployment, we have instructions in our website. There are instructions to deploy in very different environments, from bare metals with Ansible scripts, or with on AWS with Terraform and so on, or also like with Kubernetes, we have recipes and already available. So in just like a few commands, you can spin up a cluster in the cloud or in a Kubernetes cluster and have Pulsar running. Of course, like having a massive deployment will require probably some care in choosing the right hardware, and but this is just a matter of having some capacity planning and deciding how much bandwidth, what kind of disks are better for these use cases and not.
Yeah, so I think I will add a very quick overview regarding the deployment. So Pulsar is basically having 3 major components, or the 3 different subcomponents basically it requires to be deployed. The 2 we already talked, the Pulsar broker, which basically serves the service layer, where it basically client basically connects to the broker, and then it basically pass through the messages to basically produce it and to the consumer. And for the persistent storage perspective, we are using the Apache Bookkeeper, where we can actually start with 3 different Apache Bookie nodes, as Matteo mentioned. If we want to basically have at least 2, if you want to basically keep 2 copies of the data. And there is a third component which Pulsar uses, is a Zookeeper. So Pulsar uses Zookeeper to store the cluster metadata and the topic metadata. So it can basically stores the configuration information into the Zookeeper, and also for the ownership and the synchronization between the namespace and the topics. So basically Pulsar requires these three different subcomponents to be deployed. And as Matteo mentioned on the website, there are different instructions have been defined if you want to deploy into the bare metal cluster, or if you want to deploy into the Kubernetes, or on the Google Cloud with again Kubernetes, or Amazon AWS. So those instructions and the recipes are already available. So with like few minutes of the efforts, we can deploy it very easily. And then based on the capacity and the traffic, those nodes can be basically adjusted based on the traffic and the capacity.
And as you're scaling the cluster, whether it's vertically or horizontally or across geographically distributed regions, what are the different factors along which you can scale, and where do they start to break down that people should be paying special attention to as they do start to increase the overall capacity of the clusters?
So typically, say, one of the distinctive features of Pulsar is that, as we told, that we have these two layers, is that it's very easy to expand the capacity of a running cluster. And that is because the data for a single topic or partition of a topic is not stored on any one node in its entirety. So the data is over time, and that gives that we can expand the capacity. Like if we need more storage capacity, we can just add more storage nodes over time. And the same thing that can be done for brokers. So if you see that the CPU or the bandwidth for the brokers is running high, then you can just add more brokers, and automatically there is a load manager component that takes care of assigning topics to brokers, and that will also use the load information for a broker to offload some of the topics to these less loaded brokers. So these basic administration operations are automatically. So you can just spin up new nodes and the traffic will move there.
And in the event of network partition, where does Pulsar fall in terms of the cap theorem of whether it continues to operate in a partially degraded mode or whether it will cease to accept new inputs until the network partition is healed?
So the consistency model is basically broker owns topics, and they acquire the ownership through Zookeeper. So that the consistency level is guaranteed by Zookeeper. That's what gives the broker to the ownership, and that ensures the consistency. The consistency is also validated at the bookkeeper level. So there is a fencing mechanism so that if a new broker takes over anyway, that will basically it is able to fence off the old writer. So that guaranteed consistency. So again, this is more like a CP system. But again, the difference with there are different threads of the same time that Zookeeper is a CP system, but you also have multiple nodes to give you availability. So if you have a bigger quorum, you have more chances of availability. You don't have a single point of failure. That's.
And over the course of our conversation, we've mentioned Kafka a number of times as being a somewhat comparable system in terms of the way that people might use the two different projects. I'm wondering if there are any other projects or services that you would consider to be competitors to Pulsar, and if you can do a bit of compare and contrast as you introduce some of those different projects.
Sure. Like bearing all the reasons that we enumerated at the beginning, like all the scalability, dual-replication, that's features that were not there in any other system. I think that the interface-wise, messaging model-wise, there are certainly similarity between with Kafka and other systems. For example, I would mention like RabbitMQ. I would say that there are kind of like two main set of messaging systems. One that comes from this log aggregation and that evolved eventually into streaming. So Kafka was designed initially as a log aggregation system, and that is reflected a lot in its own even in its current state. Eventually, it evolved into streaming and a streaming platform now. But then you have more traditional message queues like ActiveMQ, RabbitMQ, and these are the more traditional pub/sub that have like a much more flexible API and a richer set of features in how to route messages, how to consume it. You don't have to keep track of your offset in a pub/sub typically. And the main issue with all these traditional pub/sub is that they were always lacking in the storage part. They didn't have a very solid storage and a very solid replication story. So very flexible API, but the persistency guarantee were a bit weak, and on that front. While on the other end, you have a log-based system with replication and so on, but it's a bit more inflexible. For example, it's not trivial to build a queue on top of Kafka because Kafka is each partition has one consumer, so you cannot attach multiple consumers. You can only add more partitions, and that makes building a worker queue very tricky operation. So in Pulsar, I just cut short here, but since we have both streaming and queuing a model on top of our log, so we can offer the user a very high level and easy to use API that can support both queuing and streaming, and have that based by a very solid storage and very solid horizontally scalable storage.
And is it possible for you to have two different consumers that are consuming the same topic in a different fashion, where one of them is using the more log-oriented approach where it's tracking an offset and consuming the data in a streaming fashion, and then you have other consumers that are treating it as just a shared queue and pulling whatever the most recent messages are off of it?
Yes, that is correct. So the idea there is that on a topic, when you publish, you don't have to worry about how data is going to get consumed, and on the consumer end, you can have different subscription, and each subscription is independent from the others.
And I know too that there's an API compatibility layer for people who are using Kafka. They can ostensibly just drop Pulsar into their system, add in that API layer, and continue to use their consumers and producers as if nothing had changed. I'm wondering if you have any other similar compatibility layers for being able to provide an AMQP interface for somebody who might be using RabbitMQ in a traditional queuing capacity.
Yeah, we don't have that right now for MQP. That's something that we are thinking of, but so the thing about Kafka is that most of the people are tied to the API, so it's very easy for us to basically build this wrapper, right? And this wrapper is just using Pulsar API, Pulsar client library underneath. With the MQP is that everyone can use a different client, no official client library. There's no official API. So on that front, probably would make more sense for us to build a service that speaks MQP, but that's a lot of work to do that. So that's still there in the air.
Yeah, the overall flexibility into the AMQP protocol, I can imagine, would cause a lot of complexity in terms of being able to provide a wrapper that fills all the various different use cases, and you'd probably be better suited just building to specific implementations where you want to, for instance, replace RabbitMQ for interfacing with somebody who might be using Celery with Python or some of the other task-based systems.
Yeah, that's correct. So MQP is a very big specification, and implementing the full spec will be a good amount of work.
And going back to the Kafka compatibility, I'm wondering if that goes so far as to also support some of the other tooling and plugins that are built around the Kafka ecosystem, such as the Confluent Schema Registry or the Kafka Connect implementations.
So right now we don't support the schema registry around that, but I think that shouldn't be a problem, because I think that the schema registry goes out of band from the messaging protocol, so it's not something that happens in line with the messaging, so it can be done. On the other hand, we are working on having a schema registry in Pulsar itself, so that's something that we want to integrate within our messaging protocol to ensure that the schema can be enforced and can be validated and enforced in a way. So one option would be also to use our own schema registry to validate that as well.
And again, on the subject of compatibility with Kafka, at least in terms of the conceptual models people have about it, is the idea of the message persistence. And I know you mentioned that Pulsar has the ability to maintain the log of messages that have been published to a topic. And when I was looking through the documentation, it looks like it's configurable as to how long those individual messages can be kept around for. So I'm wondering what the long-term storage capacity for a Pulsar system looks like as compared to how somebody might use Kafka for being able to do something like an event-oriented system where they can replay the entire sequence of events from the beginning beginning to end and how long those events are persisted for?
Sure. I would say that one big difference from Kafka versus Pulsar is that in Pulsar, the broker actually knows the position of each consumer. And because of that, it can, for example, the default is to delete the data as soon as all the subscription have consumed the data. So you don't need to have a time-based retention. And if some consumer is falling behind because it's down for several hours, you will not lose data based on retention because the subscription is retaining the data. By you have not acknowledged the messages, the data will still be there. Having said that, we also support retention time in addition of the subscription-based retention. So you can say that I want my data for at least 6, 12 hours or 3 days or whatever time. It just depends on space. And the other interesting difference on the storage part is that with Bookkeeper, so since as I keep repeating, the data for a single topic is not stored in a single node, that is very important because in Kafka, if you have a partition, because this partition has to be stored in its entirety in a single Kafka broker. So basically, you cannot retain data more than X amount of time because that's once you fill up one single disk of a machine, the partition cannot grow anymore. While with Pulsar and Bookkeeper, what we can do, we can keep adding new segments, and these segments are placed in different different storage nodes. So if you fill up all your disk space, you can just add more nodes, and you can still write into these nodes. So that's basically your storage capacity. It is not limited by a single node capacity.
And one more thing. So as Matteo mentioned, so the biggest difference between Pulsar and Kafka would be where Pulsar broker exactly knows what is the read position of the particular consumer subscription. So as soon as the consumer of subscription basically reads the data, Pulsar broker can basically purge the data immediately. And the second thing is the retention, where you can define how long you want to keep your messages. And the third thing in Pulsar also supports would be the message TTL. So you can also configure at the namespace level how long you want to basically keep your messages, and then once the time to leave of that message would be expired, no matter whether the subscription has read or not, it will basically be deleted. So in some subscription where they basically they are building a backlog and they are not basically able to consume the message for a long time, and it basically grows the storage, then we can have two options. One would be we can always set the message TTL at the namespace level, so message can be deleted or the data would be deleted after a certain point of duration. And second would be we can basically enforce publisher to not produce any more messages until the consumer basically consume all of the messages. So let's say if we have a certain limitation at the tenant level, that specific tenant basically can consume X percentage of the storage of entire cluster, then let's say 50 gigabyte of storage. So basically we can always enforce that a consumer basically a publisher can basically publish some messages up to 50 gigabyte of data, and if consumer are not consuming the messages, then basically we don't want to lose the data, but we want to basically force the publisher to stop publishing the messages. So it basically supports various kind of use cases where based on your retention requirement, you can either stop publisher to publish the messages, or you can basically expire the messages, so your publisher can basically keep publishing the messaging without impacting your actual storage limitation.
And also having the ability to expire the messages based on the overall amount of time that the message has spent in queue can be valuable for when the data may have some sort of expiration period inherent to it. So if somebody wants to make a reservation for a particular time and then that particular time has gone by, then it doesn't matter anymore for it to be processed. So you can just purge that data without ever having to actually use up the CPU cycles on the consumer side. That's actually a use case that was mentioned when I was speaking with the gentleman, Sean T. Allen, for Wallaroo. That was a use case that he mentioned as people requesting as well for, again, a streaming context where if the data has some inherent life cycle and you can't process it before the end of that life cycle, then you don't want to waste the computation on processing it when it's not necessary anymore.
Yes. Yeah. So each use cases has very different trades-off, and that really depends on the application, right? That's in some cases, and there are very different properties of the data and the kind of events that are being pushed in topics, and we try to be as flexible as possible to accommodate all kind of use cases, all in a single cluster, and make it work everything in a single cluster.
And given the fact that Pulsar is so scalable and adaptable and tunable, definitely seems like there are a large variety of use cases that it can be applied to. But when is Pulsar the wrong tool to use, or what are some use cases where you think that somebody should use something besides Pulsar?
I think we have seen two use cases in Yahoo where people try to use Pulsar and then we realized it's not a good match for the Pulsar. The first would be Pulsar should not be used as a database, where if people basically try to publish messages and then they basically want messages to be stored as a database perspective, right? So definitely that's not the good use case. Second would be sometimes people wanted to use as a scheduler system where you publish the message and you want to consume a message at particular specific defined time. So it's basically you are building a scheduler on top of Pulsar. So I think again Pulsar might not be the right system if you.
I would correct there, just saying that. So both of us, we have seen like a very bad scheduler implementation of Pulsar. I think that it is possible to do it in the right way. It's just that we have seen various bad implementations.
Yeah.
And
Anything else you would like to add, Matteo? Why Pulsar might not be the right tool?
Yeah. So I think that the strong points are. I mean, you can. It's kind of flexible system that you can adapt for very different things. The strong points are very in the data durability, and that the guarantee is that and the storage and the low latency and the high throughput and the fact that another thing that we haven't mentioned that is that so in Bookkeeper is the guarantees are that the data has been flashed to disk. So we are actually able to offer like very low SLAs in publish latency and high throughput while making sure that the data is actually flashed on disk. While all the other systems like in Kafka is the default is to let the page cache handle the write. So the write is actually in memory in the OS memory, and then the OS will flash it. But so when you get two acknowledgements from Kafka, is actually you have the data in two machines in memory. So you still have a lot of chances of losing that data if you have like power outage or these kind of scenarios.
And are there any particular new features or overall system improvements that you have planned for future releases of Pulsar?
I would say that some of the biggest ones from our end are more like on adding this schema registry and having a way to enforce the format of the data and have a way to also discover it so that you can build tools that will discover what kind of data was published on a topic, as long with validating and enforcing that information. Also, one other bigger feature is on the topic compaction. We're trying to basically get a snapshot of the data based on keys. And Rajan probably has other features that they're working on.
Yeah, so I think those are the main features, and the other few features we are basically trying to build would be introducing the replication service, which basically can actually replicate from Pulsar to any other system. So basically it should be pluggable. So let's say if user is basically publishing the messages into the local Pulsar cluster, and then that user would also like to publish the same messages or would like to replicate the same messages to different other system. Let's say in AWS we have Kinesis, or we would like to basically publish the messages to some other non-messaging system as well. So right now, if users are basically needs to write their own implementation where they are basically they are doing the dual publishing where they are publishing into the Pulsar as well, and second, they're basically publishing to some other system as well. So what if we can basically provide a similar feature as what geo-replication does within Pulsar, where in geo-replication, replication is basically happening right now from cluster A to cluster B within the Pulsar broker. Now it can be basically done to some other different system by adding the plugins framework within the Pulsar application service. So in that way, it will basically reduce the load at the client side, and client doesn't need to pay any attention, or they don't have to basically worry about the replication to any other different system. So we are basically building that pluggable framework where we can basically plug in any geo-replication framework, which can basically talk to any different system, and then it can basically reliably replicate the messages. Yeah, so that is another big thing which we are working right now to facilitate our users.
Are there any other topics or aspects of the project that we didn't cover yet that you think we should talk about before we start to close out the show?
No, I was thinking, do we would like to cover the multi-tenancy within Pulsar, which basically can cover the security and probably different other features like isolation and or the other different resource quota other features.
And one of the other features that we didn't talk about yet is the fact that Pulsar was designed to provide for a multi-tenant deployment where you can have isolation between different users of the system. So I'm wondering if you can talk a bit about how that's implemented at the system level and some of the security capabilities that you have built in for operators of the cluster to ensure that you don't have data leakage between those different tenants of the system, as well as some of the use cases that it provides for in a hosting context, for example, that would be impractical for some of the other systems that somebody might use in that kind of environment.
So in Pulsar, we have basically added the multi-tenancy feature at multiple layers. So right now, Pulsar provides the authentication and authorization capability, where in Pulsar we can basically plug in any authentication framework, and by default within Pulsar we are providing the default Athens authentication framework, which is another open source project from Yahoo. So authentication is basically pluggable framework which Pulsar provides, where it basically can authenticate and get the principal role of the user, and based on that role, Pulsar basically does the authorization. Right now it's basically central authorization. It's not pluggable though, so it basically provides tenant identification, and then basically it basically provides a user to use the Pulsar for publishing and consuming the messages. Another thing would be resource isolation, where it basically try to protect or isolates the resource in terms of the storage and in terms of the CPU. So in terms of the storage, as we discussed earlier, where in Pulsar we can always configure the resource quota in terms of how much storage space a user can or a tenant can basically acquire. So at the namespace level, we can always define what should be the maximum storage capacity that tenant can use, and beyond that, Pulsar basically not allow a tenant to publish the more messages or try to store more data into the disk. In that way, it can basically protects the specific tenant to acquire all the storage space within Pulsar. Regarding the CPU isolation, in Pulsar, we have recently introduced the message consumption throttling. So we can always configure any namespace or any particular topic, how many messages a consumer can basically receives. So in that way, if sometimes what happens, many different consumers, they basically try to consume as fast as possible, and in that particular topic there are the message in throughput is basically pretty high. So there could be use case where that specific number of consumer can basically eat up all the network and the CPU resources of the cluster. So to prevent that, we can always define throttling limit per consumer per topic, and which basically protects those specific consumer taking the resources in terms of the CPU and the network bandwidth. And then so those are the main multi-tenancy features Pulsar provides. Matteo, would you like to add anything else?
Yeah, I would just like mention that. So these are all like this soft isolation, basically software level protections from preventing tenants to affect each other, right? But the main core feature that enables us to provide multi-tenancy and is the I/O isolation that happens at the storage node level. And that happens because the write path and the read path are separated. So you have different devices, and you have a journal which the writes are written into and then cached in memory. And then you have a storage device which are separated physical disks, the one disk or multiple disks, that basically what gives you is that all the reads are coming from the storage device, while the writes are only synced on the ledger device, on the journal device. So the two I/O paths are separated, and that allows that if some reader is causing a lot of disk I/O, it won't impact the writers. So it won't affect the SLA of publishing latency or throughput for other tenants. And that's the feature that enables us to offer this as a service.
So for anybody who wants to follow the work that you reach up to or get in touch, I'll have you add your preferred contact information to the show notes. And so as a final parting question to give the listeners one more thing to think about, if you could just describe from your perspective what you see as being the biggest gap in the tooling or technology that's available for data management today.
That's a good question. I would say that there are very different systems with very different trades-off, and I would say that there are not many truly scalable systems, and this is something that when you choose a system people typically don't worry that much on that part, and like all these pain points that you have when scaling, you can only see that after a while, after you get acquainted with a certain system and you figure out all the operational pain point, or like when things getting more complex due to scale. And so I think that this is something that Pulsar we have been doing a lot of work on that front, and I think that something that we can help close the gap in this particular area of messaging, and not the broad data management, but in the having a single platform for sharing data across different components in a very solid and scalable way.
Rajan, do you have any thoughts on that topic?
Yeah, so I have a similar belief where whenever we are building such a scalable and the distributed system where it basically includes multiple different other components. So the system, so if I give example of Pulsar, where it depends on two other different components, which is Apache Bookkeeper and the Zookeeper. Sometimes with the scale in Yahoo, we are basically going on a very large scale of data and the number of traffics in terms of the number of messages going in and out. After it scales, we realize many different pain points which could be within the system or within the different subcomponents. So at some point, you basically hit that particular limit where you need some big change or modification or the improvement where to scale it more. It could be, let's say, within Pulsar, it could be, let's say, within a Zookeeper, where it can basically support X number of Zookeeper nodes, and you cannot go beyond that number of Zookeeper nodes, let's say, or the storage. You really have to basically come to at the ground again, and you have to basically rethink what could be done for the next step to basically build another big innings of the scalability. So, but those things basically would be always a good learning curve when you basically hit the very first milestone of the your scalability limit, and then you basically try to improve and make it more scalable and take it more further. So should be always a learning curve when you basically hit that limit.
All right. Well, I want to thank the both of you for taking the time out of your day to join me and discuss the work that you're doing with Pulsar. It's definitely a very interesting project and one that appears to solve a lot of interesting problems. So I'm definitely going to be keeping an eye on how it evolves over the coming months and years. So thank you again for your time, and I hope you each enjoy the rest of your day.
Thank you for having us and for all the interesting questions.
Thank you.